Hello, uh, I'm Simon Eggleston, and I'm currently working for the Global Climate Observing System GCOS. My main focus is on the terrestrial climate observations, things like cryosphere, hydrology, and the biosphere. Over the years, I've had considerable experience looking at fluxes of greenhouse gases. I used to work with the IPCC, producing guidelines on how to estimate emissions and removals of greenhouse gases, and then worked with the Global Forest Observations Initiative, looking at fluxes of greenhouse gases from forests. GCOS is based at WMO, and there have been a number of recent changes. We have a new chair of the steering committee, Professor Han Dolman from the Netherlands, who's taken over from Professor Stephen Briggs. We also have a new director, Anthony Ray. The GCOS Secretariat will remain based in the WMO, but will actually be closer to the observation parts of WMO, which is probably a good thing. So WMO is continuing its commitment to hosting GCOS, and together with the other co-sponsors, is looking at reviewing the governance of GCOS, aiming to make proposals to improve the relationship between GCOS and the co-sponsors primarily. And we're working on a number of different things. We're continuing to working on the ECV requirements, looking at the status report and an implementation plan. We're working on regional activities, workshops and national support to help people observe these ECVs. We're planning on how to make GCOS more effective, increase its impact. And as we're thinking about the ECVs, we're thinking more about adaptation, impacts, extremes, and the global climate cycles. So the ECV are an essential part of GCOS and come in many ways from its mandate, which was to provide comprehensive information on the total climate system, covering all the different parts of it, and meeting the needs of quite a wide range of users, from science and climate range detection to policy, both global and national, and research in modelling and prediction. So the first step for GCOS was to identify what needs to be observed and to produce requirements for these observations. And starting in 1992, this process developed and led to the essential climate variables as a concept to actually crystallize what the needs of climate observations. What is an ECV? Well, eventually it was laid down and crystallized, and a definition was produced. An essential climate variable, ECV, is a physical, chemical, or biological variable or group of linked variables that critically contributes to the characterization of the Earth's climate. The ECVs themselves are a group of parameters within all those climate system variables that are possible. And they're a subset where the observations are feasible and cost effective, but also they're relevant to the users of that information. Essentially, the ECV datasets provide the empirical evidence needed to understand and predict the evolution of climate, guide mitigation and adaptation measures. Their production was founded on climate science and climate data, and also the observational capacity infrastructure. There's no point in defining an ECV if there's no way it will be measured. And to support the ECVs, we produced a range of guidance, which include the actual user requirements themselves, which the observations try and meet. Also, observing principles and standards. These were approved by the UNFCCC and WMO and IOC, and they're the standards and principles that the climate observations aim to meet. We also produced additional guidelines for dataset preparation to support the use of the ECV. An important step in this, beyond the science and understanding the science observation, is identifying the users to understand what will be relevant. And in the past, GCOS has tended to concentrate more on the broader things of climate science and global climate policy, and also providing support nationally and globally. As we're moving forward, we're also looking more at the impacts of climate change and responses to climate change. So those identifying who the users and what the needs for these climate observations are enables us to identify what are sensible ECVs. This is a list of the ECV which were produced in 2016 in the GCOS implementation plan and have been approved by the UNFCCC and parts of WMO. They're divided into atmospheric, oceanic and terrestrial parts, which are looked after by those respective panels. But in some extent, that distinction is a bit arbitrary and made for practical considerations of which groups actually make the observations. So, for example, though we have the cryosphere and terrestrial, we also have sea ice under oceans. Each of these ECVs may have one or more sub-parameters as well. So we call them ECV products, because to define some of them, you need to know more than just one thing. The ECVs, we try and aim for them to be consistent across a number of issues. The climate system itself, and what we're trying to understand, composes of another components. There's water and carbon cycles, there's the energy balance and the biosphere. To understand each of these, we need more than one ECV. We have a number of ECVs that contribute to that. And we've set long-term understandings for the overall measurement and monitoring of these cycles. So the ECV requirements must be consistent within a cycle. We don't want something to have enormous accuracy in one part of, say, the carbon cycle and low accuracy in another. Also, a lot of the ECVs belong to more than one cycle. So, for example, evaporation is water and energy. So the ECVs must also be consistent between the cycles. It's also important to remember that a lot of the ECVs are also measured for other purposes. A lot of the atmospheric ones are measured for numerical weather prediction. We don't want to duplicate activities in other places. We need to make sure that the requirements and the needs that we identify fit into these other monitoring activities. We developed a process in 2016 to produce the ECVs that started with GCOS reviewing the status of the existing system, and then the GCOS panels consulted with the various observation communities to refine the requirements for each ECV. They then made a proposal in terms of accuracy, resolution and so forth, which was then publicly reviewed and formed part of the implementation plan that was then published and presented to the various stakeholders. Also, in order to actually make these requirements practical and see that they're met, we need to monitor how well these are observed and how well the data sets that are produced match against the requirements. We need to follow up actions identified in the implementation plan to improve the networks. We need to work with stakeholders to improve the uptake of ECVs. Stakeholders such as the European Space Agency, CCI, Climate Change Initiative, which is working on producing satellite records of a number of ECVs, the joint GCOS-CGMS working group on climate, which are planning a lot of satellite measurements of the ECVs. And finally, it's important to ensure that QA/QC is implemented for all the ECV records. The process we're following now for the update that will be published in 2022 is very similar, except that we've increased the amount of review. We've already had a public ongoing consultation, and the panels are now considering that before there'll be a second public review, and then the data will be incorporated into the implementation plan as before. So we're having greater public involvement, which we feel is quite essential in developing the ECVs. We're allowing more time for the panels and the experts to consider the requirements. There'll be greater involvement of stakeholders. And we're also asking for more detailed information and definitions of the ECVs to make it clearer what exactly is being asked. And finally, there'll be more specific consideration of different users, for example, related to adaptation and impacts. The table on the left shows the information that we collected and published for each ECV in 2016. So there's the ECV itself, there's any sub-variables that were needed. For example, here, lake area, lake temperature, and lake colour. The frequency, how often each measurement needs to be made, the resolution that was needed, the uncertainty, the stability. And stability is an important parameter for climate change, where we're trying to detect often relatively small changes over time. So we need a measurement term series that are accurate over those times to detect the change. And finally, any references and standards. This will evolve for 2022. It's very similar, the sort of information we're asking for, except we're asking for an additional element as timeliness. This is what's sometimes called latency. It's the time between the measurement before it becomes publicly available. And we're also going to ask for more than one number. So there'll be a threshold value, something that has to be achieved for the data to be useful, a goal, which is where any improvement beyond that doesn't really lead to any benefit. And then possibly in between those values, a number of values that are sometimes called breakthrough values, where there's specific benefits for specific users. So we're going to give ranges rather than individual values, which is what we did before. A final thought about ECVs, about data storage and access. Good data stewardship is essential. This is particularly true for ECVs, where we're looking at long time series. The longer the better. But it's true even for records of short duration. So they need good metadata, so the data can be found, addressed, and its provenance and limitations known. The QA/QC needs to be recorded and documented so people understand the quality of the data. There should be uncertainty estimates with the data. People need to understand that, as that provides limits on how it's used. And the data should be freely and openly available. There's not much point in collecting this data for climate and then not allowing people to use it. For satellite records, this is often largely the case, especially when it's being coordinated through the Working Group on Climate. And there are a lot of, I think about 490 records available through the ECV inventory, which lists all this information and metadata and the location of the records where they can be downloaded. They include both the climate data records themselves and what are called fundamental climate data records, which is particularly important for satellite records. And these are essentially the original measurements from the satellites, often radiances and similar. And that means that if they're stored as well, then if improved methods of deriving the parameters we're interested in for climate are derived in the future, they can be reprocessed to produce an updated climate data record. So to summarize, ECV are physical, chemical or biological variables or groups of variables, linked variables, that critically contribute to the characterization of the Earth's climate. The ECV are defined after quite a large public consultation. They're not independent. They should be consistent across the climate cycles and consider other uses. They need to be adopted internationally. They're supported, ECV are supported by the UNFCCC, the WMO, IOC and others. And I think this is an important point that gives a much more support and credibility to the numbers. It's important to help stakeholders use the requirements and involve them in the development of the requirements so that they have a stake in the process. We need to make sure the principles and guidelines are also available so people understand what is needed in terms of climate records and what are the minimum requirements. Data stewardship is important, free and open access is needed, and we've been defining the process. The process of defining an ECV has been improved and refined with asking for more detail, clearer definitions, more public and stakeholder involvement, and a range of values rather than a single number. So, thank you very much, and I hope that's provided some overview of the ECV and how we produce them in GCOS. Thank you.